Hello, good day everyone. Our topic today is this one, reentrancy and multitasking. Talking about this means talking about system performance. And talking about system performance, we must know there are three major factors that affecting the system performance. Number one, processing power or CPU. Number two, memory. And number three, input output IO. Any deficiency in one of those three factors will certainly decrease the system performance. The most common and the most fatal factor actually is IO factor. Unfortunately, due to excessive discussion on surrounding IO factors, so I prefer to talk about CPU power, processing power, and memory first. Furthermore, processing power and memory factor also actually significantly affect to the IO. Right now, we are talking about processing power and memory, specifically as in introduction of reentrancy and multitasking. Reentrancy, what is that? Reentrancy is about memory related to a program module. Programmers normally don't very care about the restriction or limitation of the usage of the memory. So they often end up with leaving words, local variables scattered throughout the program modules. Here is for example, this module. This one is assembler module. Assembler is the only way to clearly explain the internal process step by step because assembler instruction and machine instruction is correspondent one by one. That means a real mechanism in the computer processing can be described clearly using assembler. So back to this module. This module actually got the function to calculate hasil 1 is XYZ times PQR plus ABC times PQR, and hasil 2 equals to XYZ times PQR minus ABC times PQR. To simplify this calculation, the programmer got intermediate variable to make it into two steps of calculation. The step 1, calculate ABC times PQR and XYZ times PQR, and the results are kept into these two variables, ABC PQR and XYZ PQR. Then the final step is calculate hasil 1 as a result of XYZ PQR plus ABC PQR, which is actually XYZ times PQR plus ABC times PQR. Hasil 2 XYZ PQR minus ABC PQR. Very clever, isn't it? Unfortunately, behind this brilliant idea, the programmer unknowingly sacrificed the computer performance. If this module is going to be shared among users, if it is not shared, so no problem. Next, let's say this is this module and this is a user. User 1. User 1 provide data here. In this logics, it calls to this module. As long as this module is only used by this user alone, it is no problem. Because ABC PQR will consistently consist of product of AB01 times PQ01, and XYZ PQR will consistent to keep the result of XY01 times PQR. But what happens if the situation is like this? User 1 and user 2 share this module. What is going to happen? ABC PQR supposed to be consist of product of AB01 times PQ01 from user 1. At the same time, it also got to be consist of product of var01 times var03 from user 2. So what is the actual content of this variable? Unpredictable. So what is the solution? The solution, operating system will provide separate copy of this module for each user, like this, right? So what happens if there are thousands users? Certainly, if there are 10,000 users, there are 10,000 copies of niche in the memory, and it become contention to the memory. So what is the solution? The same module should be only one copy in the memory. So the solution is like this. This is the same module as explained before, but local variable ABCPQR and XYZPQR are removed from this module. Means no part of this module is modified anymore. Those two variables then taken by users here. I said this users data instead of this module data because it's only dummy. This structure is dummy structure to map the user's data. The algorithm of the calculation are still the same. When user 1 wallet got to provide the data like this, ABO1, XYO1, and PQO1 still the same. SSL101, SSL201 also the same, but before that inserted these two variables. This module will calculate using this algorithm based on data provided by user 1. The same way if it called by user 2. It will calculate data from user 2 like this. This module is reentrant. When you build the module, you must tell to linked data to mark this module is reentrant. Reentrant module is actually loaded only once for the first load. Subsequent load will be only provide the copy of entry point address to the caller. Okay, at the moment talk about reentrancy is enough. Thank you for watching. Good day.